All right, in this video, we're going to be talking about multiplying rational expressions. So keep in mind, rational expressions are essentially two fractions with polynomials in the numerator and the denominator. When you're multiplying fractions, you always multiply across. That means the numerators get multiplied together and then the denominators get multiplied together. So we have a couple steps here. First thing we want to do is we want to factor the numerator and denominator completely. After that, we're going to combine as one fraction, meaning we're going to multiply. So remember, once again, you multiply across on top, multiply across on the bottom. Step 3, we want to simplify. Now remember, with simplifying rational expressions, we want to make sure we list the excluded values. Excluded values are values that make the denominator 0 in the original equation, but don't make the denominator 0 in the new equation. So it's essentially things that we've crossed out and that we no longer see anymore. So starting with this first example, we are going to factor in the numerator and denominator of each of these. So when I look at the first one, x cubed plus 3x squared, I can take out a GCF of x squared. That leaves me with x plus 3. In the denominator, I have a trinomial. It's going to factor to two binomials because the first term is x squared. X needs to go in both of them. You are multiplying to a negative number, so that tells you that your signs have to be different. One with a plus, one with a minus. The way that we multiply to negative 6 and add to positive 5, positive 6 and negative 1. In the second fraction, we have trinomials with x squareds in both of them. So numerator and denominator is going to factor as two binomials with x's in front. In the numerator, you're multiplying to a positive number. It's positive 9. That tells us the signs are going to be the same. Because we're adding to a negative, both signs need to be negative. Factors of 9 that add to 10, 9, and 1. And then in the denominator, you're multiplying to a negative 27, tells you your signs are going to be different. The numbers that multiply to negative 27 and add to negative 6, that's positive 3 and negative 9. So that's our step 1, factor the numerator and the denominator. Step 2 is to combine as one fraction. So basically, you just multiply this all together. So it becomes x squared times x plus 3 times x minus 9 times x minus 1, all in the numerator. In the denominator, once again, just multiply it all together. Remember, factoring is undoing the distributive property, so we don't really want to FOIL here because you're just going to create more work for yourself. If you factor early on, it makes it a lot easier. Now this should look pretty similar to things we've seen before. We're now able to just cross off what common factors we have. So I see an x plus 3 in the numerator. I can eliminate it with the x plus 3 in the denominator. I see an x minus 9 with an x minus 9 and an x minus 1 with an x minus 1. What you're left with then is x squared over x plus 6. And we want to make sure we list our excluded values. So anything that I've crossed off that I no longer see in the denominator. I crossed off x minus 1. If I plug in 1 there, that would give me 0. I've crossed off x plus 3. If I plug in negative 3, that would give me 0. And I've crossed out x minus 9. If I plugged in positive 9, that would give me 0. So in this case, you have 3. That's your final answer. All right, when we look at our second example, same thing, we're gonna start from the beginning. We're gonna factor where we can. I can't factor this x plus 3. That's as simplified as I go, so I leave it alone. But to make it easier, I'm gonna add parentheses around it. In the denominator, you have a GCF here. It's a GCF of 2x squared. What we're left with is x minus. Now, the biggest mistake that I see people make is they forget to add this term. If you are factoring the entire thing out, I hear a lot of people say, I'm left with nothing or I'm left with 0. Remember, it's undoing the distributive property. You need a placeholder there. Technically, you're left with x minus 1. If you start with 2 terms, you should still have 2 terms on the inside of your parentheses once you factor out 2x squared. And then for my second fraction, once again, I've got trinomials with x squareds at the front. We're factoring to binomials. I'm multiplying to a positive 6. I'm adding to a negative 7. That's x minus 6 and x minus 1. In the denominator, I'm multiplying to a positive 21, adding to a positive 10. That's x plus 7 and x plus 3. Step 2, combine it as one fraction. Go ahead and multiply everything together. Numerator comes together as 1. Technically, you don't need to include this step. I like to. I think it keeps it a little bit more organized. But if you want to go ahead and eliminate after you've factored, that's fine. As long as you're crossing something from the numerator with something from the denominator, it works perfectly. All right, so now I'm going to go through. I'm going to cross off what I can. X plus 3 with x plus 3. X minus 1 with x minus 1. You'll find that some teachers prefer, after you've done this, to go ahead and now distribute and multiply everything through in the denominator. I tend to just keep it in the factored form. I think it looks a little bit neater and a little bit cleaner. That's my simplified form. And then we list our excluded values. So x cannot equal, no longer see x minus 1, so that's positive 1. And I no longer see x plus 3, so that's negative 3. Final answer. For example 3, the first thing that you should notice in this one is I have a fraction and then I don't. What we can do, though, to make this a little bit easier is we can go ahead and change this to a fraction. I can make this a fraction by writing this x squared plus 3x plus 9 over 1. It's going to make it a little bit easier for us when we actually go through to factor and when we go through to multiply. So when I look at the first fraction, x plus 2 is not going to factor further. Once again, I'm going to put it in parentheses just to make it a little bit easier. What you should notice in the denominator is you have 2 perfect cubes. We know that the sum or difference of cubes is going to factor as a binomial, so 2 terms, times a trinomial, 3 terms. What I usually say is we ignore our signs to start. We have a way to remember that we're going to include here at the end. I ask myself the question, what do I cube to get to x cubed? The answer is just x. Then what do I cube to get to 27? 3. Our pattern for our trinomial is we square the first, so I square x and I get x squared. For the middle term, I multiply these together, so 3x. And then for the final term, I square the 3, so 9. Our pattern for our signs is same, different, addition. So I do the same one that I start with, that's minus. I do the sign that's different from subtraction, which is addition. Same, different, addition, the last sign is always plus. You may look at this trinomial, this x squared plus 3x plus 9, and try to factor it. In this case, it's not factorable, so you just have to leave it alone. But once again, I'm going to keep parentheses around this, so it's a little bit easier. Okay, once I factored, I combine it as one single fraction. Once again, if you want to skip this step, you are more than welcome to do that. I'm going to include it just to be consistent. What you're going to notice here is in this case, our trinomial cancels out for both of these. So what we're left with is x plus 2 over x minus 3. As far as excluded values go, the only way to find these is to plug into quadratic formula, so we kind of just usually ignore that. We only find the excluded values if they're easy factors that we can set equal to 0. Because also in this case, our excluded values, if you were to plug that into quadratic formula, are going to give you imaginary solutions, which we don't worry about.